Everyone. Thanks everyone for coming. Danny and myself, we're welcoming you to this talk about creating powerful mixed reality experience across auto. We're from an agency called Trigger. I'm the CEO, grew up in Asia, came to UCLA for graphic design, started Trigger in 2005 after starting a different company. And I have 4 patents in AR play, but I'm more of a creative concept guy. So all the technical questions should go to Danny.
Hey, I'm Danny Parks. I'm the Senior Director of Technology for Trigger. I joined in 2013, and since joining have over 100 mixed reality projects that we've worked on.
So before diving into the automotive side of things, we have 125,000 hours of mixed reality development. So our first AR project was actually in 2009. It was mobile, like webcam-based AR for Sony Pictures. It's worth noting, let's talk about what is mixed reality in the first place. We see it as a kind of a spectrum. It's not one sort of deliverable, but it's basically the kind of intersection between physical and digital content. And that spectrum can go from, very cosmetic. You have a digital layer that's sitting on top of, something physical and they don't really talk to each other, to something much more meaningful where the digital and the physical are completely entwined and talking to each other and interacting with each other. And there are things, I think, for us that are VR might be considered mostly a digital experience, except for the 6-DoF movement. But in our cases, sometimes, we'll show you an example where it's in-car, pulling from the vehicle's telemetry and stuff like that, where we feel that's definitely a mixed reality sort of experience. So in our building of this number of hours of experience, a lot of it came from our tech partners. Just an important note in this case, I think, especially in this industry that's changing so fast, like not only understanding the user side, but understanding the technology and the platforms behind it is super critical. So everywhere from on the more consumer marketing driven side, like partners with Snap and Facebook, to more of the hardware solution like Magic Leap, and then of course the software side with Google and Vuforia. Some of our clients, so we started in entertainment, but it's a big spread from entertainment to sports to big brands. And of course, on the automotive side, we work a lot with Honda Innovations, Honda Advanced Design, Nissan, and Toyota. So quickly, just to overview, before we dive into some of the case studies on mixed reality in auto, just how mixed reality can be applied across this industry. And we feel it has extremely broad applications from on the enterprise side, starting with the design team, actually, concepting out these vehicles, designing these vehicles, and then all the way to the consumer side, from in dealership to even kind of Snap and Facebook sort of applications where it's kind of social AR type of marketing. But I think mixed reality has usefulness, runs a gambit from end to end. So on the design and development side, we'll show you something where we're using augmented reality for volumetric review. That's where the executives and designers can actually see a car life size and get a sense of its proportions, which is very difficult to do on screen. You need the ability to walk around it, and it's traditionally done in clay. Of course, being able to annotate that and collaborate remotely. So a lot of our clients have multiple design studios. So you might be a LA studio with the parent in Japan, in Tokyo, and having those 2 teams being able to collaborate using mixed reality is extremely powerful. And then, of course, validation by executives. The other thing is actually that's being worked with now is actually using mixed reality in the design process itself. Not only for the review, but actually instead of sketching on paper and then going into 3D, like sketching in VR or sketching in AR. So the first initial idea of the car is already done in mixed reality. So on the manufacturing side, training is getting really big. I don't know if you guys, in a different industry, it was Walmart, I believe, that had just ordered 1,700 Oculus Go's, I think, for all their training in their stores. So kind of VR-based training, AR-based training is going to take a big leap from there, I think. Helps people through complex assembly. You can, of course, train them before they actually get into the assembly process. And then there's a big focus on field and remote assistance. So you have a lower trained person out in the field, something breaks down, they can connect to the manager who can see exactly what they're seeing and help them through that process there. And then maintenance, just being able to walk through a factory and see all the pressures and gauges and information in mixed reality space. Functions and features of the vehicle itself. This is quite interesting because right now when we're in the car, it's small displays. It got a little bit bigger quite a bit bigger with Tesla. But the cars that are rolling out now have multiple displays. And of course, the design teams that we're working with now are working on cars that are up to 2035. So in that case, if you think about the importance of the human-machine interface, the HMI experience, whereas a few years before that was a radio and your speedometer. If you project 10 years from now, like how much interaction will you have with the digital world around you as you're driving through the streets? So everything from heads-up display, what's the passenger experience? Are there external displays on the car that are communicating with pedestrians and other vehicles? All that has to be can be enhanced by mixed reality. And then, of course, sales and marketing. Once the car's designed and built and stuff like that, how do you get consumers to buy the car itself? And I think in mixed reality is super important, I think, because even if you look at commerce and other types of shopping with furniture and things like that, it's basically like an 11x improvement on conversion off of just a simple photo. So if a person can actually place their vehicle, life size, configure it, it's on their driveway, how much further does that get them to purchase? As well as being able to, as the cars get more and more complex, to be able to show some of the safety features and the complexity of those features in mixed reality, and we'll show that as well. And then finally, the ownership experience, so being able to track the owner and their loyalty throughout the car ownership period of time, reward them, help them with maintenance, help them self-diagnose, as well as make their own repairs and things like that. So into the case studies. So our first project in automotive using mixed reality was actually for the LA Auto Show in 2016. We partnered with Honda and Lego, and we won the Developer Challenge. And then we won again with Honda in 17. But wanted to start and focus on the 16 one. So in 16, it was actually a really interesting project. The design challenge. So LA Auto Show is a big auto show. The design challenge is a very big event, especially for the car companies. But the challenge was to design the car of 2050. And our approach was, instead of us designing it, let's get the kids to design it. Since Lego was a partner, and we feel like these kids will be adults by 2050, so let them design their own car of the future. So we brought them into the Lego offices. They built out any idea that they wanted. There weren't that many constraints. And then we picked the best of designs that were then taken back to the Honda team. The Honda team then riffed off of the kids' designs, and the kids were brought back in to see kind of the evolution of their work. But the end of this process was to show the kids themselves those vehicles life-size in the studio using mixed reality. So I'll just play a little video. So here we took the Honda assets. The kids could walk 360 around the vehicle. Their youngest kids were 7, I think. And the amazing thing was that there was no instruction. We had worked with kind of AR for a long time before, and it was quite finicky. This is Tango, and you could just hand these devices to the kids, and they could walk straight in and out of the vehicles and stuff. And I think the power of this was, and the Honda designers saw it themselves, was that kind of instant volumetric review, and the fact that it was so simple that an 8-year-old could do it. So. Excuse me. So besides being cool, like that instance got Honda very interested, but it has to solve a bigger problem than that. It can't just be, oh, that's interesting, or that's an innovative way to do volumetric review. What are we actually solving? So if you think about a design funnel for automotive, and generally it goes from sketches to 3D to some sort of volumetric review, which is typically done in clay, and then a full mock-up and final design. You'd think it would work in this kind of shape, but in fact, it works something like this. And the reason is that you start off with many ideas, and they quickly cut down to 2 because of cost and timing. A clay model for volumetric review takes about 8 weeks, and car companies are spending about $50K a month just buying blocks of clay. So a lot of design ideas are being lost because you're cutting down the options at a very early stage. So if you could bring in mixed reality and show more cars volumetrically and have them reviewed volumetrically, we can retain better ideas and hopefully get to better options further down the design funnel. So what we built was we used HoloLens at first, but it was a volumetric review design tool. They could look at multiple concept cars at the same time. They could change the colors. They could look inside the cars. They could rotate them. They could see all the technical measurements and stuff, all in AR in their kind of legacy process, which is they like to review the cars outdoors against physical competitor cars in full sunlight, which was quite challenging. So here's a quick video of the latest port of this. So we can't show, of course, the concept vehicles that we worked on. So this is a slightly simplified version with a generic model or a bought model. So there's a bumper button that will bring up a menu for choices and controls and stuff. We're not showing much of it in the video, unfortunately. And Danny can kind of talk about the evolution of the tool.
Yeah, thanks, Jason. So if we kind of look back to that original LA Auto Show piece, historically, kind of set the stage. This is 2016. This is before ARKit and Core, as we all know and love. And we are trying to place a full-size vehicle in a room with kids. And we've done a lot of work with image markers. You know, model targets hadn't quite come out yet. So the real challenge here is, like, how do you make this something that you don't have to train a bunch of people to go out and use, and then you can just hand it to them. And at the time, Google Tango had just kind of come onto the stage, and you know, it's a hardware. It's got a depth sensor in the back, and it gives you some really amazing tracking capabilities. So, that's kind of where we're at. We can now place a model. The tracking is rock solid. It has some kind of understanding of the mesh around it. So it's on the floor. There's occlusion with other objects in front of it and things like that. And this is kind of a big eye-opener for everyone involved, right? Like, oh, you mean I don't have to have an image target? I can put this wherever I want? That's amazing. So fast forward to, okay, well now we have the HoloLens. We are now no longer holding a tablet. This is a HMD-based solution. And again, we're able to put things in space without markers if we need to. But we're still talking about essentially mobile devices. So we need to really think about, okay, the guys who are doing CAD, their digital designs are, they're parametric, right? It's curves and splines and NURBS, not polygons. So Unity is all about polygons, and we need to figure out what does our pipeline look like for not changing the way the designers are working, but being able to take the work that they're doing and put it into our process, put it through our pipe to get the assets that we need. And there are some really great tools out there. The Autodesk tools that they are working in have some native capabilities to do the decimation that we need to get the assets down. You guys have probably heard of PixYZ. They've got some great stuff as well. So that pipeline is not this big barrier of a guy spending another 80 hours on your asset, chipping away at the poly count to get it down to something that'll run on a mobile device. So now that we can take assets directly from the designers, we've kind of solved that issue, that big bottleneck of, okay, well, now we can get it into AR. All right, well, how does that fit into their review process? The big review process, like Jason was saying, was they're bringing in these executives to look at a physical thing. So they build out a clay model, they roll it out into a courtyard, they have the competitor vehicles lined up around it. It's outdoors, it's at noon, it's big bright sunlight, all of the worst possible things for HoloLens to deal with. But the idea is there, right? You can see, okay, here's the model, here's its volume, here's its shapes. We want to make as much of that physical space present in that visualization as we can. So we're taking environment maps, pulling them in at runtime to make sure that the reflections and the shadows are correct. We've got a process where they can go out, drop a 360 camera, say it snows in LA. They put it out there, within a couple of hours, our environmental map has now got snow in it. So that sense of presence in that model is something that is not just kind of, well, we've got day, night, and overcast. We can really anchor it to the space they're in. So if we want to do it on an interior environment, we can do that too. And we've talked a little bit about kind of the evolution of these devices. That evolution isn't stopping, right? We've done this for ARKit, AirCore, Magic Leap, HoloLens, basically any device that's out there, we're trying to put this on it. Because they all have different affordances, right? Like the tablets, yeah, you've got to hold something in your hands, but at the same time, you don't have optical pass-through to deal with. You can draw black, 100% black, it's fine. So really the key here is like Unity's cross-platform deployment. Being able to deploy to whatever your studio has got, whatever tools they already have in their inventory, that's really powerful. One thing we have to be aware of there though is that we're designing our inputs and our modalities for how users are going to interact with that to match the tools that people are using, right? So not every device is going to support voice commands or gesture controls, but the ones that do, we want to make sure that where it makes sense, we're doing those. And, like, it doesn't necessarily matter what affordancy you have in the digital if the physical doesn't necessarily allow for it. So, when you're outside in bright sunshine, maybe optical pass-through isn't your best friend. You're never really going to be able to control the physical environment in the same way that you can the digital. So understand that space as much as you can and work around it. Take advantages of the affordances that it gives you. So in a beautifully well-controlled environment like this, where you have control over the lighting, whatever you want, right? Like, put HoloLenses on people, put tablets in people's hands, whatever makes sense. But if you are in an environment where there are some constraints, take advantage of those, and like, pull in that lighting data if you've got it. But don't necessarily try and fight it if the optical pass-through isn't going to work at all. Don't worry about that, because you can find a technology that will solve that eventually.
And then one thing to mention is that since this tool has been put into production and it's being used on multiple projects, what we're discovering is that it's actually splitting into two different types of user groups. So there's a use case, of course, with the executives for review, and these guys might only use it, let's say, 3 or 4 times a year. Some of them are flying in from Japan, in which case the tool and the controls and stuff have to be quite simple. You don't want to spend a lot of time, putting on devices, getting them to fit right, and then having to teach them how to do different gestures and all that sort of stuff, especially for a review. But then there's another use case where it's like the actual designers of the vehicles, something that you can give them a lot more complex tools, where they can, even on a day-to-day basis, go straight from a design on their desktop to bloop, go out to the parking lot and check it out volumetrically and just go back into their room. So it's an interesting thing to consider, that you need to be that flexible to kind of account for that kind of evolution as well. So a case study on the sales and marketing side. This was a campaign that was in all of Nissan's North American dealerships, so US and Canada, around the time of The Last Jedi. So we did the AR campaign for Star Wars on the kind of entertainment side of our work. But we worked with Critical Mass here, which was Nissan's ad agency for this piece. So basically what happens is, it's ambassador driven. You go into a dealership, the ambassador will hand you a phone, and the phone will transform the vehicle, and there's 3 total vehicles, into a Star Wars one. So full replace, and then other Star Wars vehicles and characters will come out and explain all the safety features of the car in more of a storytelling experience versus, kind of cold, dry numbers. So it was really a successful campaign for Nissan. I think they're saying the retention or understanding of the technology was like a 70% increase through this versus their traditional media and traditional brochures and salespeople just trying to explain that stuff. But the tech itself was actually a pretty complicated experience. So.
Yeah, so on the surface, this looks like just another, draw a digital thing over a physical thing. This is actually really cool. So what we're doing here is, again, this is in that time before ARKit and ARCore. Model targets and CAD Reco are just barely starting to become a thing. And we try it. We go out and we create some model targets, and they recognize okay, but it's not perfect, right? There's a fair amount of kind of either misalignment or misrecognition. It's not the Nissan Rogue it sees another vehicle. So we're doing 3 vehicles here, and it can't tell the difference between the 3 of them. It's looking at the badge and like, oh, they both have badges. That must be the same thing. Great. So what we ended up doing was, because that alignment has to be so perfect and so precise, we're using the Tango again, but we take an NFC sticker and we put it in a particular spot on the car, and then you go and you put your phone up to that NFC sticker. As long as you're still for long enough and it detects that sticker, we know exactly where that phone is on that car. And that gives you that kind of calibration between physical and digital worlds. So now everything is in line, and you can use the tracking for the Tango to keep those two worlds in sync, and it works beautifully. So you've got this amazing replace of like, okay, there's that physical car, and then it just gets painted over. That wipe is a really, really impressive moment for being able to say, okay, now we're still in that physical thing, but we have really and truly put digital on top of it. So now that we can do this, like, what are we going to do with it? Great, you found a car, you painted the car, awesome, good job. Now what? So we're trying to bring kind of the Star Wars property into this to tell a story about the safety features that are really important to Nissan. So they've got some really advanced tech in their cars, and they want to use the Star Wars franchise to tell that story and make people understand what this is capable of. And anytime you're working with Star Wars, it's an incredible honor and an incredible challenge. The ILM guys, like, everything matters to them 100%, right? You can't phone anything in. And that's what makes it so great. Like, you look at a hologram and, okay, it's a hologram, right? No big deal. But if you look at the history of Star Wars, the holograms evolve every film, right? The effects we're doing have to be Last Jedi holograms, not Episode 4 holograms, right? And there's a lot that goes into that, and especially when you're talking about what's on mobile. So, we're writing custom shaders to create this effect. The poly counts have to be as high as they can possibly be to get the level of fidelity that we want. We're using PBR materials to really try and make sure that the lighting and the reflections and everything is looking as clean as we can get it. All at the same time, like, this is running on a mobile phone in 2016, right? It's not the same kind of compute hardware that ILM is used to. So there's a lot of challenges and a lot of trade-offs there. The real trick is being able to push as far as you possibly can without losing the ability to do what the tech needs to do. So if you're going to start dropping frames because you need a full screen render pass, that's not an acceptable trade-off, right? You have to be able to strike that middle ground, and it's all got to be in service to the story. So we're talking about full-size vehicles, full-size X-Wings and full-size TIE fighters, and if anybody knows, those are big. And we're in potentially a dealership, right? So it's, we don't have control over that space anymore. So there's going to be some occlusion issues. Holograms are great for that, but we want to keep everything as tight to that car as you can. If you think about the commercials that you've seen for automotive safety features, they tend to have kind of a lot of top-down establishing shots. You can't really do that. You can't crane up your people with their device at every dealership. So you have to figure out ways to tell that story from the perspective of the user. And that's just really about being aware of, what is the field of view of this device? What is the physical size of this vehicle? How close can I bring these characters in, still have them tell the story, make the movements that they need to make without making everything feel super crowded? And that's really kind of a massive creative undertaking to figure out, okay, legal requires that this car be moving 13 miles per hour. How do you show a car moving 13 miles per hour coming to a stop in about 6 feet, you know, especially when you're in a dealership and you may only have 5 feet to do this. So there's a lot of, again, the space is kind of your best friend and your worst enemy all at the same time. Yeah.
Yeah, I definitely think that in our history with kind of these large mixed reality campaigns, the reality part is the tough piece, you know, and often overlooked. So all the way from just basic communication to the consumers to let them know that something's available or that they should point at it to do it, to all these space issues in locations that we have very little control of. So those things should be started to be solved at the very beginning of the project. Like that should be an active discussion through the whole thing versus waiting until the very end and then trying to solve it later. So on the ownership experience side, this is something we did with Connected Travel and Honda Innovations. It was presented at CES a few years back. It has since progressed and matured, and it's going through a pilot program and things like that now. So there'll be some exciting news to share about this later. But it's actually a VR in-car experience. So play a little video. So we're running a couple of Vive headsets. We're driving through Vegas, and it's like a one-to-one match for your location and movement from the physical world to the digital world. And the proposal is that in the digital world, you can kind of clean everything up, as well as bring in all these other layers of data. So things like Yelp and commerce and, you know, all your wayfinding and things like that can all be presented in VR space.
So this is probably one of the coolest projects that we've worked on from a pure tech standpoint. If you can imagine, this is just kind of base level. What are we trying to do here? We're trying to put VR in the back of a car and drive you around a digital space with a car. So you get that right, and it is the greatest roller coaster ride you've ever been on. You get that wrong, and it is the worst roller coaster ride you've ever been on. And you've got to get it really right. So we have a digital world, right? We've got a map of Vegas, okay? How good is that map, all right? How good is the GPS in your car, right? You go out and you open up Google Maps on your phone, and you see that blue circle. That's a problem, right? That's a pretty big circle when you're trying to get people exactly on the street. And you know, if you start walking around at very low speeds, where is that orientation going, right? That's a huge problem. So what we ended up doing is tying into the CAN bus data from the vehicle. So there was a shot in the beginning where the trunk is full of hardware, right? There's you know, a whole bunch of batteries, inverters, computers, little servers in there. So we're pulling the raw data from the car, like velocity, acceleration, braking, heading. All of that is coming in. We're fusing that with the GPS data that we've got and trying to come up with our best estimate for where you are on the street. And then we're going in and fudging the streets to make them a little bit wider so you're not driving through walls. Because, you know, no data is perfect, right? And the important thing is that experience still makes sense, that you're taking all that data, you're bringing it in, making as rich of an experience as you can have without putting so many constraints on yourself that the whole thing feels broken. So, you know, we're looking at this as, okay, there's a lot of data out there, but it's still largely 2D. You know, if you look at kind of OpenStreetMaps versions of 3D models of cities, they're extrusions of footprints, which is okay, but, you know, not great. That's coming, right? You get into Google Earth and it's getting a lot better. So that data is out there, and it's going to be more relevant and more accurate and more exciting. The hardest piece to tackle in this, again, is VR in the back of a car. Everything shakes in a car, no matter how smooth that ride feels. When you're trying to do like inside-out tracking with a Rift or a Vive, it's all going crazy. So you just have to kind of, again, the physical pieces, control what you can. Put dampers on your physical motions. Again, inside-out tracking may not be the greatest thing if you have to have lighthouses. So we kind of moved away from the Vive to a more optical-based solution with the Rift. And again, we're looking at this as kind of an example of what could come next. So as the HMI in the vehicle changes, right? Maybe we're not wearing headsets in the future. They're power hungry, they're big. Maybe the whole display, the HMI around you is just complete screens 360. But what this is a glimpse of what's possible. And you do this once and you're like, oh, okay, let's look at the future of what cars are. They're going to be self-driving. They're going to be, data rich. This is a slice of what that could be, how this experience could play out.
Yeah, I mean, we're looking at basically, you have this captured audience that are spending literally years of their life in vehicles, right? Like, what is the next level of pushing entertainment and content to those passengers? So, and then a quick bonus. This is actually, I believe, being shown at the Vuforia booth as well. Hot Wheels, we actually worked on this, their flagship toy that's coming out this holiday season. It's a mixed reality track. And I'll just play the video.
I didn't see this coming.
How many times have we heard the words?
This changes everything.
This changes everything.
This time, they were right.
Introducing Hot Wheels Augmented.
This is the future of racing.
It's a head-to-head battle.
Featuring augmented reality.
It's total immersion.
Using smart device technology. Weapons acquired.
Control of the track is in your hands.
Fire your weapons.
I'm hit.
Enter the pits to repair and recharge.
I'm back in the race.
Battle it out and go for the win.
It's a battle.
Adults assemble. App and Wi-Fi required. Smart devices not included. This changes everything.
So yeah, so when we're talking about the spectrum of how connected digital and physical is together, like this is really pushing what can be done right now. Like the track is fully talking, of course, to the device, and then the cars are being controlled by the track. So. Yeah,
so this is, again, every interaction you have with this track is through your device now. So we've really kind of gone all in on the physical to digital interface. So we've got a Bluetooth Low Energy connection between your device and the toy itself. Since you can only have kind of one of those pairings, and this is a multiplayer experience by design first and foremost, that second player is connected to the first player through Wi-Fi. So there's a lot of work that goes into kind of making that as seamless as possible, right? Because this is a kid's toy. You don't want to have to be an IT expert to go and set up your Christmas toy. So trying to make that journey from unboxing to playing as smooth and seamless as possible is kind of, again, it's all about the physical product and your physical space. So from a design perspective, you have to kind of keep that in mind all the way through everything you're doing. It's about fun, You want to have as much fun as you can with this toy. That's its point. It's a toy. So, we're looking at this not from just, okay, what does the tech have to do to support that, but, what is the game here? We're looking at, okay, we start with paper prototypes. We start with digital prototypes. We go back and we rebalance them over and over and over again until, we're satisfied that, okay, yeah, this is something that you would actually want to go and play. Because no matter how cool the tech is, if it's not fun, it's still not fun. Tech will only take you so far. And again, talking about that physical digital interface, we can control what the track is doing, but those little cars are super fast. And sometimes they fly off. And that can't be a game-breaking experience, right? You have to know that something could go wrong in the physical space, and you have to account for that. So we have, there's a limited amount of information we get from this track, right? We get, there's a lap counter, there's a state of charge meter. We know when the gates are open, we know when the charging pit is closed. But the cars are so fast, you can't track them optically. So we are, counting, like we expected to see that car come back and we haven't seen a new lap get counted. It's probably gone. Let's pause the game. Tell the kid to go pick up their car and put it back in. So again, it's really all about, okay, how do you take advantage of what little information you have about the physical world and tying that into the digital experience to kind of make the most of it. So we're tracking like, okay, how many laps can a car do on a charge? All right, well, let's remind them that, hey, now might be a good time to pit. If you just had a physical toy, you might not be able to it's up to the user to learn that behavior on their own, but now we can kind of guide them and really craft their experience to be something, that is what we want and what we envision when we imagine it. Kids having fun with this product. And one last note about the physical, right? Like once you ship that toy, it's out of your hands. It's so hard to update physical product. You got to mail kids new tracks. That's not really an option. So, we're trying to build in as much future-proofing as we can. So the firmware can be updated over the air. It's super easy to update, the software on your phone. Push in App Store update, and it's live. But getting that onto the device in a safe and secure way is a big challenge, but it's something you have to do, right? Because the technology is going to evolve, and if Apple comes out with a change that is suddenly bricking your experience on this physical toy, that's not okay. You have to do what you can to anticipate that and account for it before it happens. So again, think about the future as much as you can. And, with kids, it's always about kind of safety and security. So don't do anything that, even has a whiff of, like, we're talking about model target tracking. And the questions we're asking is like, okay, well, is any point in this process, is any of the images coming off that camera feed leaving that device? Is it going anywhere? And that's a hard no, right? You cannot have that. I'm sure there are other people who may be a little softer on that line, but for us, it's an absolute no. Just because it's kids, you want to be as safe as you can, and you don't have control over the user in AR, right? Like that camera could be pointed at anything.
So it looks like we're out of time. We'll leave up, just slide this top 10 takeaway slide up so you guys can take a look. We won't really get a chance to walk through it, but we'll be available outside for questions. I think the one thing I hope that we've kind of shown through this is that, mixed reality is really invention right now. So every project's completely different. Every project has a whole new set of problems to solve, and that's in every industry, and especially in automotive, that's kind of pushing innovation so much. And I think that Unity brings this kind of flexibility and power to it that can allow us to have a single team apply to many of these projects and have this continuity for the client that it would be very difficult to do if it wasn't for Unity. So, but thank you very much for sitting through our presentation. Thank you.